We talked about standard position last time. It's when we're in the XY plane and our vertex of our angle is at the origin and our initial side is on the x-axis. And then our terminal side is going to go to wherever, whatever angle I tell you. Okay, so we'll make it however large it's supposed to be. If it's a positive angle, we're going to go counterclockwise. If it's a negative angle, I can draw pretty much the same angle, but we're going to go clockwise. Okay, now, there are some really special angles that we use a lot. And after we finish up this lesson, we're going to be talking about the unit circle, and that's what it's all about, is these certain angles. So, if I take, no, that's not very good. Any circle, and by any circle I mean of any radius, of any size, we know that the full rotation of the circle is 2 pi. So we're going to be working in radians. We're going to do a little both, but we're going to start using radians mostly. The full circle is 2 pi, right? So over here I'm at 0 degrees, and if I rotate all the way around, I get to 2 pi. And we talked about a straight angle last time, or halfway around the circle, is pi. The special angles divide this up like it's a pizza. Okay, so I'm going to work from 0 to pi. Well, that means up here, I've cut that half of a pizza in half. So I get pi over 2, right? That's halfway in between 0 and pi. If I cut that in half, I get pi over 4. That would mean on the other side in quadrant 2, I get 3 pi over 4. And we're going to keep going for the second half of the circle. And what I do to fill them in is I just count my pi over 4s as I go around the circle. So I start at 0, and then I say this one is 1 pi over 4. And this one is 2 pi over 4, but 2 pi over 4 reduces pi over 2, right? Then I get to this one, I say that's 3 pi over 4. This one's 4 pi over 4, which reduced to pi. That makes this one 5 pi over 4. And that makes this one 6 pi over 4, which reduces to 3 pi over 2. And then we get 7 pi over 4. And if we go back to 0, we would get 8 pi over 4, which reduces to the 2 pi. Okay, we're also going to do it for sixths and thirds. But if I count up by 6, then I'll get the thirds by reducing fractions. You'll see in just a second. All right, so everybody with me? All right, so let's do the other special angles. Not a very good circle, but it'll work. And I know this is 0 and 2 pi. I know this is pi. And the ones that are on the axes, the x and the y axes, are called quadrangles because they divide our circle up into quadrants. So I'll label those because we got them from the last one. Okay? But if I'm dividing up into, well, it'll work if I divide it into 6. If I'm dividing into sixths, that means between 0 and pi, I want 6 pizza slices. That means between 0 and pi over 2, I want 3 pizza slices, right? So I'm going to mark these 1/3 of the way each, right? So that gives me 3 pizza slices. And then I'll go 1/3 of the way here, and here, and here. And so I've divided between 0 and pi now into 6 pizza slices. Do you see that? There's 1, 2, 3, 4, 5, 6. So when I'm counting around this time to label them, I'm going to go by sixths. So I've got 1 pi over 6. 2 pi over 6 is going to reduce to pi over 3. 3 pi over 6 would give me the pi over 2. 4 pi over 6 is going to reduce to 2 pi over 3. Then I have 5 pi over 6. 6 pi over 6 is just pi. 7 pi over 6. Then I'm going to get 8 pi over 6, which will reduce to 4 pi over 3. 9 pi over 6 will reduce to 3 pi over 4. This should be 3 pi over 2, y'all. I'm sorry. I make mistakes a lot. You need to speak up, correct me when I do. So that one was 9 pi over 6. Simplify that by dividing by 3 over 3, and we get 3 pi over 2. That's how I caught my mistake. All right, so that's 9 pi over 6. Then we get 10 pi over 6, which reduces to 5 pi over 3, and then 11 pi over 6. And if we kept going, I'd get 12 pi over 6, which is back to 2 pi. Okay, so if I know these angles, and you're going to get real familiar with them real quick, then if I give you an angle in radians and tell you to draw it in standard position, it should be pretty easy to approximate where it goes. Oops, not the right page. All right, so we're going to draw some angles in standard position. When you do this in my math lab, they're going to be multiple choice. But when you do it on a test, you're going to have to freehand it. Or at most, I'm going to give you the x and the y axis. Okay? Now, the first one we're going to do is 4 pi over 3. Now, I just did that one a second ago. And I did it by counting up by sixths. So 4 pi over 3 is actually the same thing as 8 pi over 6, right? So let's just count around our circle. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. So we start our angle on the x-axis. We draw the terminal side where I just figured it out by counting around. And then we need an arrow to indicate that I went in the positive or counterclockwise direction. All right, let's try negative 7 pi over 4. This means we're going to rotate in the clockwise direction, and we're going to count backwards by fourths. Okay, so if I'm going by fourths, but I'm going backwards, this would be negative pi over 4. Then we've got 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So we start with our angle, initial side on the x-axis, terminal side is pointing there, and I need to show that I went in the negative direction. So what does that tell you about negative 7 pi over 4? It's the same as what? Same as pi over 4. All right, we good? Okay, what if I give you 14 pi over 3? Okay, now let's do it down here. I don't have to turn that into sixths and count it. If I see, let's go back to where I did it, where the pi over 3's happen. If I count around the circle, the pi over 3's happen. We've got 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And I've turned my half a pizza into 3 slices. Do you see that? So if it's over 3, I don't have to count by sixes. But if you're happy counting with sixes, count by sixes. I just want to show you that it's possible to do it this way. So if I do that, then for 14 pi over 3, I'm going to get 1, 2, 3, 4, 5, 6. We went all the way around. We got to keep going. Let me change colors. 7, 8, 9, 10, 11, 12, still not there. I'm going to change colors again. 13, 14. So we started on the x-axis. We went around, and let's go ahead and do, we ended here. And we went around once. Then we went around, that wasn't supposed to happen. We went around once, then we went around again, and then we got to there to draw our terminal side. Okay, so if we do a full rotation and then some, you got to show that in your little arrows in the center. Okay, they ask you to do them in degrees. That's a little bit easier because we're more familiar with regular numbers over radians, right? So there will be a couple problems where they give it to you in degrees. But for the most part in this class, most of the time we work in radians. Okay, what is a full rotation? 360. So this is going to be more than a full rotation, right? By how much? By 45 degrees, right? If I do 405 minus 360, I get 45 degrees. So 45 degrees, if the whole thing's 180, that's 90. 45 is the same thing as pi over 4. So here's going to be my 45 degrees. That's going to be my terminal side. But to get to it, we show a full rotation and then some. Okay, so we've done it twice now, and you didn't know it because I hadn't told you what the vocabulary is yet. But we found coterminal angles. coterminal angles have the same initial side and same terminal side, but a different number of rotations. So 405 degrees is coterminal with 45 degrees. Let's go back a second here. We saw that negative 7 pi over 4 was the same thing as pi over 4, right? So those would be coterminal angles. Ugh. I did not write down what I said out loud. Okay, in your homework, you're going to be asked to find coterminal angles, and generally they're going to ask you to find them between 0 and 360 or between 0 and 2 pi. So for this one, if I was going to do that without drawing it to figure out where it is, I would go, well, if I need it between 0 and 2 pi, I can't have negative, right? So what I want to do is add 2 pi to it. Well, if I'm going to do that, I need a common denominator. So 2 pi is the same thing as 8 pi over 4, and that gives me pi over 4, which is between 0 and 2 pi, so that's my answer. Really? What I'm going to do instead of finding common denominators and working with fractions is if it's in radians, I'm going to type negative 7/4 plus 2 into my calculator. I'm going to hit the math fraction button, and it's going to tell, so it'll give me a decimal, and I showed you guys the math fraction button last time. It's going to give me 1/4, and then I'm going to put the pi back on it. For the 405 degrees, if I ask you for a coterminal angle between 0 and 360, I know that's more than 360, so I'm going to subtract 360 from it. And that would give me 45 degrees, which is between 0 and 360. So I'm good. What if I'd given you 905 degrees? You subtract 360, it would still be over 360, right? You keep going and repeating the process until you get it between 0 and 360 or between 0 and 2 pi. Your calculator's your friend. Don't do these in your head. Okay, we have one other thing. It's a little thing to do in this lesson, but hold on, I'm going to stop recording.